In our second part of this chapter, we ended our discussion of portfolio return and risk with mentioning that the way that we calculate or the way we measure risk in a portfolio concept is through something called beta. While beta is derived from the capital asset pricing model, or Capm. And Capm is that particular theory links together risk and return. Capm suggests that there is a security market line that states that a stock's required return equals the risk-free return plus a risk premium that reflects the stock's risk after diversification. So here's the formula for the security market line. So it is the equation for a straight line, and it says that the return on stock I is equal to the risk-free rate plus the product of the stock's beta times the market risk premium. The market risk premium is equal to the return on the overall stock market minus the risk-free rate. So I've worked a couple of examples for you using the security market line equation. So from your textbook, problems 8.3 and 8.4, I've worked for you. When you click on this link, it'll bring you to a Show Me tutorial. I'd also like you to look at the video reviews end of chapter walkthrough for problem 8.10. So beta, our measure of risk in a portfolio context, that is market risk, the primary conclusion is that the relevant riskiness of a stock is its contribution to the riskiness of a well-diversified portfolio. So it depends on its contribution to the whole. Beta measures a stock's market risk, and we know that market risk is that risk that cannot be diversified away. Beta shows a stock's relative volatility in comparison to the overall stock market. So it indicates how risky a stock is if the stock is held in a well-diversified portfolio. In our video reviews, there's a concept clip about beta, and I'd like you to watch that. Some comments on beta. If a stock's beta is 1, that stock or that security is just as risky as the average stock. That's because the stock market's beta is always 1, regardless of whether we have a bull market or a bear market. The stock market's beta is always 1, and then stocks are measured in comparison to the overall market. So if a stock has a beta greater than 1, that security is riskier than the overall stock market, or riskier than the average stock. If a stock has a beta less than 1, that security is less risky than the average stock, or less risky than the overall stock market. Most stocks have betas somewhere between the range of 0.5 to 1.5. Your author poses this question: can the beta of a security be negative? Well, yes, it theoretically could happen. In that case, the security market line would slope downward and the beta would be negative. However, a negative beta is highly unlikely in the. So how are betas calculated? Well, actually it's a regression line, and we use historical information and run a regression of this straight line and come up with the beta coefficient for that stock. In this class, we're not going to run any regressions. We are only going to use the security market line and solve for beta when beta is unknown, and we know the rest of the inputs to the security market line equation. So for problem 8.5, I've worked this problem for you. So if you click on this link, you will see what I'm talking about. Now, what exactly is the market risk premium? It's that part of the equation that's in brackets, of the security market line equation that's in brackets. It's the additional return over the risk-free rate needed to compensate investors for assuming an average amount of risk. It's that part of the security market line equation where we take the return on the market and then subtract out the risk-free rate. We call that part the market risk premium. Its size depends on the perceived risk of the stock market and investors' degree of risk aversion. It's going to vary from year to year, but most estimates suggest that it ranges between 4 and 8%. We can also calculate portfolio required returns using the security market line equation. Instead of using a stocks beta, we are going to use a portfolios beta in the security market line equation. And here is a problem that I've worked for you. It's problem 8.2 from our textbook. There are a couple of other problems worked for you as well. If you go to the video reviews, end of chapter walkthroughs, 8.7 and 8.10 are worked for you step by step. Again, I suggest you try working these problems on your own and then watching. Did you get the same answer? Certain factors that change the security market line. Remember, earlier I said that the security market line is just an equation for a straight line. So if inflation affects if investors raise their inflation expectations, what happens to the security market line? If that happens, well, then the entire line shifts up. If risk aversion changes, then the slope of the security market line will change. So here are a couple of problems where we see changes in the security market line, much like the two previous slides, problems 8.11 and 8.12. So watch the video reviews of these end of chapter problems.